Hi all. Once again welcome to the lecture series of electrical machine design. So in the last videos we have discussed about the output equation of single phase and three phase transformers. So in this video we are going to find a relation between the EMF per turn and the output kVA of a transformer. So as we know that transformer design actually starts with selection of an appropriate value for EMF per turn. That is, we can denote it as ET. That is, EMF per turn is ET. Okay, so we have to derive a relation between ET and Q. Okay, that is output kVA Q. So the equation for EMF per turn can be developed by relating output kVA, magnetic and electric loading. So in transformers, the ratio of specific magnetic and specific electric loading is specified rather than actual value of specific loadings. That we know that we learn later, that is about the specific magnetic and specific electric loading. So here we are taking a ratio R such that it is a ratio of specific magnetic and specific electric loading, that is R is equal to phi m by AT, where AT is the mmf value. Okay, so with that ratio R, we are going to find a relation between ET, that is EMF per turn, and output kVA Q. So we are start with the kVA per phase equation Q, that we know Q is equal to Vp Ip into 10 raised to minus 3. Vp is the primary voltage and Ip is the primary current, and we know that this Vp is approximately equal to Ep, that is the EMF developed in the primary, induced in the primary. As we know, Ep is equal to 4.44 FIM TP. Okay, so that we are substituting here 4.44 FIM TP into Ip into 10 raised to minus 3. And here we know that this TP into IP will be the mmf of the transformer. Okay, so we are denoting it as AT, capital letter AT. Okay, we know that the primary and secondary mmf will be same. Okay, so for commonly for TP, IP and TSIS we are taking AT, capital letter AT. Okay, and from this previous equation, this AT will be equal to, what will be the value of AT? AT will be equal to phi m by R. Okay, that we are substituting here. Instead of this AT, we are substituting phi m by R. Okay, so the equation becomes Q is equal to, okay, Q is equal to 4.44 F phi m square. Okay, F phi m square by R into 10 raised to minus 3. Okay, and from that we are going to find the equation for phi m. Okay, we are just rearranging to find the value of phi m. Okay, so we will get that phi m square will be equal to, from this equation phi m square will be equal to Q into R. Okay, Q into R divided by 4.44 F into 10 raised to minus 3. Okay, and phi m will be equal to root of Q into R into 10 raised to 3 divided by 4.44 F. Okay, that is this 10 raised to minus 3 taken into the numerator, so that it become 10 raised to 3. Okay, and we know that the equation for EMF per turn is equal to, that is in the previous lectures, that is while we are deriving the output equation of transformers, we have taken EMF per turn ET is equal to 4.44 FIM. Okay, so we are just substituting the value of phi m, okay, phi m in this equation. Okay, that is ET, we will get it as ET is equal to 4.44 F into phi m. Instead of this phi m, just substitute this value, root QR into 10 raised to 3 by 4.44 F. Okay, and by simply cancelling some value, that is we are taking inside the value 4.44 F into, that is to inside the square root. Okay, so 4.44 F will be cancelled, and at last we will get it as 4.44 FR into 10 raised to 3, okay, into root Q. Okay, we are just separating the value of root Q here. Okay, that is because this term, this entire term will be a constant. We are taking it as a value K, constant value K into root Q. So the relation between EMF per turn and output value, output kVA Q will be equal to ET is equal to K into root Q, where the value of K is equal to root 4.44 FR into 10 raised to 3, that we know. Okay, and instead of this R we can substitute for phi m by AT, like that. Okay, so this value of K will be different for different types of transformers. For a single phase shell type transformer, this the constant K will be in between 1 to 1.2. Okay, and for a single phase core type it will be 0.75, in between 0.75 and 0.85, and for a three phase shell type the value of K will be 1.3, and for three phase core type, and if it is a distribution transformer, the value of K will be 0.45, and three phase core type, and if it is a power transformer, the value of K will be in between 0.6 to 0.7. Okay, so I hope all of you understand the relation between, how we can derive the relation between EMF per turn and output kVA Q. So thank you.